So in this problem, first I'm going to notice that it says at a constant rate. And so that tells me that it is going to be linear. It's going to be a line. It's going to be a constant slope. So of course there are some ways that you could try to figure this out without actually writing the equation of the line, since this one doesn't specifically say that you have to. But I'm going to go ahead and do it that way, writing the equation of a line. And I'm going to kind of it's going to almost feel like cheating a little bit. I'm going to try to make my life as easy as possible. As I said in another video, mathematicians, we're notoriously lazy / efficient. We're going to go for the most efficient way that we possibly can. Sometimes it might seem like we're being a little bit lazy, but we're just trying to be efficient. And so what I'm going to do is I'm going to make x be this first year, the number of years after this first year here. So let x be the number of years after 1991. And the reason I'm going to do that is that it's going to really save me a lot of work here. I'll show you in just a second. I'm also going to say, you know, and I don't want to deal with these numbers in the thousands. I don't want to have to keep writing those zeros over and over again. And so let's let y be thousands of dollars. So y is going to be in thousands. Okay. So then what that means is that these points right here, this first one here, the x is going to be 0. That's the key of why this is going to make my life so easy. And then instead of having to write 24,000, I'm just going to write 24. Well, then I have to think, okay, 2007, how many years after 1991 was that? So you can either think, all right, it's 9 more years to 2000, and then 7 more years, 9 more years, 7 more years, that's 16 years. You could go ahead and actually just subtract 2007 minus 1991. Either way, got to figure out that that was 16 years later. And then, again, I don't need to write the zeros. I can just say 55. Okay. Now here's why this is it's so efficient it almost seems like cheating. If this point right here, if the x is 0, that means that this is my y-intercept. That means I already know the b. And so I just need to find the slope. I'm not going to have to do a whole bunch of more work of finding the y-intercept. So let's just go ahead and find our slope, and then we'll be ready to write our equation. So I'll have 55 minus 24 over 16 minus 0. So 31 over 16. And it's kind of a ugly looking slope, so I'm really glad that I did this efficient method where I don't have to do any more work with that. I can just write my equation. If this is the y-intercept, that's the b. Now the only downside of that is I do have to think a little bit more about kind of what these numbers and represent, what things mean. So 2024, I can't just plug in 2024. I can't just plug in 24. I have to think, okay, so if I'm starting in 1991, how many years later is 2024? Again, you can always just subtract if you need to, but that's going to be 33 years later. And so that's what I'm going to substitute into my equation. So y equals 31/16 times 33 plus 24. And of course, you can use a calculator for that. And the calculator will tell you 87.9375. Now, let's stop for just a minute here. Remember, this is supposed to be how much Mr. Babbitt is making in the year that he retires. I don't think Mr. Babbitt would be very happy making $87. That's in a whole year. That's not a whole lot of money. Remember, I was trying to make my life easier, not writing all those zeros. Y is in thousands of dollars. So it made my life easier around here. I didn't have to keep writing zeros over and over and over again. I just have to remember at the end then to interpret this, understand what this means. I'm going to have to multiply this by 1,000. This is 87,000. So Mr. Babbitt, according to this model, would be making $87,937.50. Now, if I want to see how long you would have to work to make $100,000, well, now this isn't a value for X that I'm looking at. This is a value for Y. Um, and of course, I made Y be thousands of dollars, so I'm just going to look at the 100. Now I'll substitute the 100 for Y. And then I'll solve for X. Of course, you could fraction bust if you wanted to here. You could multiply everywhere by 16. I'll just work with it. So I'm just going to subtract the 24 first. I'll have 76 is 31/16 times X, because then I can just multiply by the reciprocal. This would definitely be a calculator problem, so I would just do that in my calculator, and that would give me that X is about 39.226. We're always going to round to 3 decimal places in this class. And so again, though, you have to interpret that. So the few different ways that you could say it, you could just keep that number. You could say, well, what number is that? That's about 39.226 years after 1991. So from that starting year of 1991, he'd have to work about 39 plus more years. That's one way you could say it. That's perfectly fine. Another way you could do it is take a look at, well, what year is that? So you could say, all right, take the 39, add it to the 1991, and you would get 2030, a little bit after with that little decimal there. So you could say something like until partway through 2030, something like that. Doesn't have to be word for word, of course, for this. Just the idea that you have to explain this. You would have to use some words here. If I say, how long does he have to work, you can't just say a number. You have to give some sort of context. You have to explain what your number means. Something like that. You could also take a look from now. He's still working at Helix now, so how many more years would he have to keep going to make $100,000? Well, this is 2020 right now, so to 2030. And so you could say about 10 more years, that 10.226 more years from 2020, from now. So something like that. There could be other ways that you could express it, as long as you're expressing it in some way that it's clear that it's a time and there's a specific reference to, so that we know exactly what kind of timing we're looking at.